Yes. Good morning, my dear good evening, my dear students. Good evening. Today, in this session, we are going to discuss numerical problems on Henry's law and as well as yes. Good evening, my dear students. Good evening, my dear students. My name is Lakshmanarana. This is Ellen Brand of Chemistry. Today, we are going to discuss the previous year questions which are discussed today afternoon session based on the Raoult's law and Henry's law. Some more questions what they're asking in the previous examination of EAPCET that we'll discuss now. So look at here. Based on the Raoult's law I told, and then based on the Henry's law. The Henry's law is, I told that partial pressure of the gas is equals to mole kH into, that is mole fraction of the gas. This is the formula we are discussing, right? The next, based on Raoult's law, that we are discussed, it is then PA, it is equals to P naught A into mole fraction of A. Then in case PB, it is equals to P naught B into mole fraction of B. According to the statement, I told that partial pressure of the gas is directly proportional to mole fraction of the gas. Partial pressure of each component in the solution is directly proportional to mole fraction of that component. Partial pressure of each component in the solution is directly proportional to mole fraction of that component. Then P total, in case if you want to take, sir, according to the Dalton's law, PA plus PB, then P total equals to P naught A into mole fraction of A plus P naught B into mole fraction of B. These are the formulas we are discussing. Right here, one more formula I told that partial pressure of the gas, it is equals to mole fraction of the gas into P total. This is from Dalton's law of partial pressure, I told. Dalton's law of partial pressure, I told. So based on these formulas, what type of questions they are given, that we have to discuss now. So look at in the previous EAPCET examination, what are the questions are given, that we'll discuss. The first question based on it is, this is given in the 2025 May 4th, 2025 May 4th kitchen question. The question, what will be there? So observe the question carefully. In the mixture of liquid A and B, in the mixture of liquid A and B, if the mole fractions of component A, if the mole fractions of component A, observe the question carefully, component A, mole fractions of component A in vapor phase, and liquid mixture or liquid mixture or X1 and X2 respectively. Then the total vapor pressure of the liquid mixture is, then the total vapor pressure of liquid mixture is, this is the question. Then, so the given data they are mentioned, that is where P naught A and P naught B are vapor pressures of pure A and B, that is mentioned. Then options are, sir, option A, P naught B into mole fraction of 1, that is then mole fraction of 2. Then option B, P naught B into mole fraction of 2 divided by mole fraction of 1. Then option C, P naught A into mole fraction of 2 divided by mole fraction of 1. Then option D, then P naught A into mole fraction of 1 divided by mole fraction of 2. These are the options, sir. Observe the question carefully. So the vapor phase and liquid mixture, both, in the both cases, the component mole fraction of component A in vapor phase and liquid mixture, in the liquid mixture, mole fractions are mentioned, that are X1 and X2. So actual ga vapor phase to unna relation, according to Dalton's law, now only we are discussed, that is pressure of A, it is equals to mole fraction of A into P total. I told that. Sir, in the place of this, they are mentioned in the place of this, that is X1, vapor phase. This is actually the mole fraction in vapor phase. Remember, vapor phase, ఇది vapor phase లో ఈ vapor phase లో ఉన్నదాన్ని X1 గా మెన్షన్ చేశాడు. Then, so in the place of this, if you keep X1, then P total will be there like this. This is the formula. One more. Then liquid phase యొక్క mole fraction తో relation ఉన్న one more formula ఏంటి? So that is PA according to Raoult's law it is. ఇదేమో Dalton's law. So this is according to Raoult's law. According to Raoult's law, if you take, sir, PA equals to P naught A into mole fraction of A. This is in mole fraction in liquid phase. Mole fraction in liquid mixture, man. Liquid mixture. Clear, my dear students, right? So in the place of XA, we can take it as X2. So PA, it is equals to P naught A into X2. We can take X2. So now the P total is required. So in the place of PA, in this formula, where in this formula, E formula lo, PA place lo, then this equation we can substitute, this term we can substitute. Yes, substitute in this, look at, in the place of PA. So what will be there? P naught A into mole fraction 2 equals to mole fraction 1 into P total, right? P total. So now what is required? Total vapor pressure ante P total is required. So P total kavalante em cheyali? Then mole fraction of 1 when it is sent this side, then P naught A into mole fraction of 2 divided by mole fraction of 1. So this is the answer for this. So P naught A into mole fraction 2 divided by mole fraction of 1. That is the answer for that. Understand, my dear students? This is one of the important question. So based on the both relations, so note down the question carefully. So who's that? Jagan Karthik. What's a mole? What's a mole? Jagan Karthik. So Babu, it is not a mole concept. In the same channel, the one more video will be there, that is mole concept video. If you see the mole concept video, then it will knows that is what is mole, then what is Avogadro number, then all the terms will be there. So generally mole nothing but Avogadro number of particles is equals to 1 mole, or otherwise then we can say, in case for the gases, 22.4 liters of any gas at STP conditions, that is equals to 1 mole. Then or otherwise gram molecular weight of this substance, that is also equals to 1 mole. Clear, my dear students? Yes. So next question we'll see. Next question we'll see. Next question based on same Raoult's law and Henry's law. Raoult's law and Henry's law. One more question we'll see. That is the question number 2. Dry air contains dry air contains 79% of N2 and 21% of O2 at temperature T kelvins. If Henry's law contains, Henry's law constants for N2 and O2 in water or 8.57 into 10 to the power of 4 atmospheres and 4.56 into 10 to the power of 4 atmospheres. The ratio of mole fraction of N2 and O2 dissolved in water at 1 atmosphere is this is the question. Observe the question carefully. The ratio they're asking. So options are 4:1, option B, then 1:4, option C, then 2:1, then option D, then 1:2. Yes, look at the question carefully. Yes, my dear students. So look at the question carefully. Say the air contains 78 or 79% of nitrogen and 21% of oxygen. So approximately take it as air contains 80% of, just assume it as 80% of N2, then 20% of O2. Take it like this. So when 80% is nothing but the mole fraction of N2, you can get it is 0.8, right? Then mole fraction of O2, you can get it is 0.2. Clear, my dear students? Right. So now if the Henry's law constants are mentioned for the both, that this is for the KH they are mentioned, that is 8.57 into 10 to the power of 4. Then for this KH value it is equals to, so 4.56 into 10 to the power of 4, right? Both KH values we got. Then next what will be there? The ratio of mole fractions of N2 and O2 dissolved in the water at 1 atmospheric pressure is, that is the question actually. Say Henry's law, the partial pressure of N2 gas equals to then KH into the mole fraction of N2 gas. Then from this mole fraction of N2 gas equals to then partial pressure of N2 gas divided by KH, right? We can take KH. Then same thing, same thing. Sir, here partial pressure of O2 it is equals to then KH into mole fraction of O2. Then mole fraction of O2 is required, means partial pressure of O2 divided by KH we can take, right? So both ratios are required. Both ratios are required. Both ratios are required. So here observe the thing, the partial pressure of N2 and partial pressure of O2 are required now. So how can you find out the partial pressure of N2 and O2? Yes, partial pressure of N2 and O2, how can you find out it? Sir, here the mole fractions are mentioned. So from the mole fraction we can find out it is, that is the partial pressure of N2 equals to then mole fraction of N2 into P total we can take, right? So P total what will be there, sir? Sir, 1 atmosphere is there. So partial pressure of N2 also we can get it is 0.8 into 1, nothing but 0.8 only. Even here partial pressure of O2 equals to mole fraction of O2 into then P total, that mole fraction of O2 I told that 0.2. So partial pressure of O2 equals to 0.2. So now partial pressures we got, then mole fractions of N2 and O2 if you take, yeah, mole fractions of N2 O2 we can take. So here I will take, so observe that here I will take the mole fraction of N2 divided by the mole fraction of O2 equals to the mole fraction of N2, what will be there? Partial pressure of N2 divided by KH. Partial pressure of N2 of this, O2 of this, right? Then partial pressure of N2 what will be there? 0.8 divided by the KH value 8.57 into 10 to the power of 4. Yes, then divided by this one, so that will go up. So when it is reversed, if you take KH value of this, that is 4.56 into 10 to the power of 4, then divided by, so partial pressure of oxygen 0.2, right? Understand, my dear students, right? So 2 ones are, then 2 fours are. Next, so 10 to the power of 4, 10 to the power of 4, both will be cancelled. 4.56, then 8.57, approximately both are doubled, right? So 4.56 once times, then this is 2's, then here 2 ones are, then 2 twos are, then you can get 2:1 ratio. This is the answer for this, 2:1 ratio. Understand, my dear students. So note down the question carefully. Yes, note down the question carefully. Then once again listen. So first మనం ఇందులో ఏం చేస్తా ఉన్నాం, నైట్రోజన్ పర్సెంటేజ్ ఇచ్చాడు, that is 79% is given. So that I told approximately 80% take it. Then here 20% take it. So 80% అన్నప్పుడు మోల్ ఫ్రాక్షన్ 0.8 అవుతుంది, 20% అన్నప్పుడు మోల్ ఫ్రాక్షన్ 0.2 అవుతుంది. సో ఈ మోల్ ఫ్రాక్షన్స్ నుంచి ఏం చేయాలి, పార్షియల్ ప్రెజర్ ఫైండ్ అవుట్ చేయాలి. పార్షియల్ ప్రెజర్ ఈక్వల్ టు మోల్ ఫ్రాక్షన్ ఇంటూ పీ టోటల్. పీ టోటల్ క్వశ్చన్ లో ఇచ్చాడు ఎంత, 1 atmosphere. సో 1 తో మల్టిప్లై చేస్తే మళ్ళీ అదే వాల్యూ వస్తుంది కాబట్టి, సో పార్షియల్ ప్రెజర్ ఆఫ్ N2 ఈక్వల్స్ టు 0.8, దెన్ పార్షియల్ ప్రెజర్ ఆఫ్ O2 ఈక్వల్స్ టు 0.2. when both partial pressures are, if calculate, then KH values already is mentioned in the question itself. KH values are mentioned. What they are asking, mole fraction of N2 divided by mole fraction of O2. ratio of, look at the question, the ratio of mole fraction of N2 and O2. So the both mole fraction of N2 divided by mole fraction of O2, if you take, then you can get 2:1 is the answer. Clear? Clear? Understand? Yes, note down the question and answer. Then we'll see one more question based on it. I would like to know, who is that? Jagan Karthik. Sir, please see chart. Yeah, of course. What is the mole you're asking, right? So mole nothing but I told you, Avogadro number of particles, also 1 mole. Gram molecular weight of the substance, also 1 mole. Or otherwise we can say that in case if gases, if you take at STP conditions, 22.4 liters of any gas also is equals to 1 mole. So that is what Jagan Karthik, yes, note down that. So we'll say next question, it's up to where it is covered. Yes, subscribe my channel, then share it. So like my channel first. So like the channel first. Hello. So hi. Yes, is that visible, my dear students? Is that visible? Hello. Something is done. All right. Is that visible? Okay. Yes, look, my dear students. The next question we'll discuss. Subscribe my channel and share my channel. So next question we'll discuss. That is this question that when in the 2024 man, May 10th kadina question idi. May 10th kadina question. So that we are discussing here. The question number 3, at 300 kelvins, 0.06 kg of an organic solute is dissolved in 1 kg of water, is dissolved in 1 kg of water. So observe the question carefully. The vapor pressure of solution, at 300 kelvins is 3.768 kilopascals. If vapor pressure of water at same temperature is 3.78 kilopascals. What is the molar mass of the organic solute? What is the molar mass of organic solute? Organic solute. This is the question. So options are mentioned here: 180, then 120, then 340, then 260. Look at the question carefully, my dear students. Look at the question carefully. Observe the question carefully. Yes. Yes, look at. So here, actually the vapor pressure relation, it is non-volatile solute containing Raoult's law of the formula we have to use here. That is relative lowering vapor pressure equals to mole fraction of solute. Relative lowering vapor pressure, nothing but here P naught A minus PA divided by P naught A equals to mole fraction of solute. Yes, the mole fraction of solute, nothing but here we have to take the mole fraction of solute, number of moles of solute divided by number of moles of solvent. So in this question, so P naught A is mentioned. Look at vapor pressure of water, the pure water they are mentioned. That is what we told, that P naught A, it is equals to 3.78 kelvins. Even PA is mentioned, the solution, that is 3.768 is mentioned. 768 is mentioned. So what is required? Here organic solute weight is mentioned. Then solvent weight is mentioned, that is 1 kg. Then water molar mass, that is 18 gram mole inverse. We know that 18 gram mole inverse. The mole fraction of molar mass of solute we have to find out. Molar mass of solute find out cheyali from this formula. So look at here, the number of moles of solute divided by number of moles of solvent, nothing but, sir, here the number of moles of solute NB, it is equals to WB divided by, then MB you can take, right? The number of moles of solvent is equals to WA divided by, say, MA you can take. So WB nothing but weight of solute divided by molecular weight. Then even here weight of solvent divided by molecular weight of the solvent. So in the place of this, we are substituting NB nothing but what? NB nothing but WB divided by, say, MB. Then sir, WNA nothing but, so now when it is going reverse, then you can get like this. This is the formula. So in this formula, this term is required. Molar mass of the solute is required. Molar mass of solute is required means what we have to do? So the molar mass of solute, that is MB, it is equals to, look at. So this term P naught A reverse avutundi. P naught A. Ee term ila reverse avutundi at vaipu velte. P naught A divided by P naught A minus PA into WB into MA divided by, that is WA. Clear? Clear? Understand all of you? Radia, high. Is a high. Yes, for the next question is, yes, for the next question is, the fourth question it is at, fourth question it is at T kelvins, 0.1 mole of non-volatile solid was dissolved in 0.1 mole of non-volatile solute was dissolved in 0.9 mole of a volatile solvent. The vapor pressure of pure solvent is, the vapor pressure of pure solvent is 0.9 bar. 0.9 bar. What is the vapor pressure of solution? What is the vapor pressure of solution? This is the question. So look at the question carefully. Options are there. 0.89, then option B 0.81, then option C 0.79, then option D 0.71. These are the options. Look at the question carefully. 0.1 mole of non-volatile solute is mentioned. Then that was dissolved in 0.9 moles of volatile solvent. So number of moles of B is mentioned 0.1. Number of moles of A is mentioned 0.9. Clear? Right. Then the vapor pressure of pure solvent is 0.9. Then what is the vapor pressure of solution? That is the question actually. So P naught A value is mentioned, that is 0.9. So PA value is how much? That is the question. PA value is how much? So according to second Raoult's law, that is relative lowering vapor pressure P naught A minus PA divided by P naught A, it is equals to mole fraction of solute, nothing but, sir, here the number of moles of solute divided by, then number of moles of solute plus solvent have to take. Then number of moles of solute, what will be there? 0.1 is there. So then total number of moles, 0.9 plus 0.1, then 1, then you can get 0.1 here. Clear? Right. Then P naught A value is 0.9 minus PA divided by 0.9, so equals to 0.1 will be there. Clear? Right. So now when it is sent 0.9 that side, from this 0.9 minus PA equals to, then when it is sent that side 0.09 you can get, right? So now 0.09 send this side, then PA you can get, it is PA equals to 0.9 minus 0.09, that is equals to 0.81. So answer is 0.81. Once again, look at my dear students. So according to the Raoult's law, so we have to take this formula. What is that formula? Relative lowering vapor pressure of solution, it is equals to mole fraction of solute. Mole fraction of solute, what will be there? Number of moles of solute divided by total number of moles. Number of moles of solute, what will be there? 0.1. Then total number of moles are, so 0.1 plus 0.9, then 1, then you can get 0.1. So in the place of P naught A, what you have to take? 0.9. Then PA we have to calculate. 0.9 minus PA divided by 0.9 equals to 0.1. Then 0.9 when it is sent that side, you can get 0.09. Then PA, if you want to calculate, PA equals to 0.9 minus 0.09, then you can get 0.81. Okay, yes. So look at my dear students, note down the question. Now one more question we'll discuss. Yeah, one more question we'll discuss. That is question number 5. Question number 5. So this question is given in the 2024 May 10th kadina question idi. May 10th kadina question. So question is, at 300 kelvins, the vapor pressure of toluene and benzene are, the vapor pressure of toluene and benzene are that are 3.63 kilopascals and 9.7 kilopascals respectively. What is the composition of vapor? What is the composition of vapor? What is the composition of vapor in equilibrium with 0.4 mole fraction of toluene. 0.4 mole fraction of toluene. This is the question. So look at options are mentioned: 0.40, 0.60, 0.80, 0.20. So look at the questions carefully. So 4 questions, observe it carefully. At 300 kelvins, the vapor pressure of toluene and benzene both are given. So one is toluene, one more benzene. Toluene P naught A, just assume it as P naught A, that is equals to, they are mentioned as 3.63. Then P naught B, that is assume it as the 9.7 kilopascals. Even here also kilopascals. Okay, clear? P naught values are mentioned for both. Then what is the composition? What is the composition of vapors? What is the composition of vapor in the equilibrium with 0.4 mole fraction of toluene? So here toluene mole fraction is mentioned. The mole fraction of one component when it is mentioned, the mole fraction of benzene we can calculate, right? That is 1 minus mole fraction of A component. A component is what now? The toluene, right? So 1 minus 0.4 equals to 0.6 you can get, right? So here from this PA you can calculate partial pressure of A. Partial pressure of A, it is equals to 3.63 into then toluene mole fraction. Toluene mole fraction is 0.4. Then P B you can calculate, that is 9.7 into that is 0.6. 0.6. Then both mole fractions when it is multiplied you can get PA and PB. Then based on that we can calculate P total, right? P total is what? PA then plus PB. PA plus PB we can calculate. So when it is multiplied with this, when it is multiplied, just multiply here. 363 into 4. 4 3s are 12. Then 24, 24, 24, 25. Then 3 4s are 12, 12 plus 2, 14. So after the 3 decimal points, then 1.452 you can get. So this is 1.452 plus. Then what about the P naught B? So 9.7 into, so 97 into 6. So 6 7s are 42. Then 9 6 ja 9 6 ja 54, 54 plus 4, 58. Then after 2 decimal points, so 5 point, you can get it is 5.82. Then 5.82 when both are added, so 5.82, then 1.452, 452, then 2, the 7, then here 8 plus 4 12, then 5 6 7 7.272, that is P total, right? So okay, we got the P total, but they're asking in the question is, so what is the composition in the vapor phase? So vapor phase lo composition find out cheyali ante, so what we have to do, man? The vapor phase composition, how can you find out it is? So look at vapor phase of any component. In case if you want to find out, then partial pressure of A divided by then P total. In case mole fraction of A component is toluene, just assume it as toluene. Then PA value, how much we got? PA value that is 1.452. So 1.452 divided by then 7.272, that you can get 0.2. So this is the mole fraction in the vapor phase. So answer is 0.20. Understand all of you? Okay, right. Next question we'll see. So next question based on the same, sir, I will give that is homework for you people. Yes, please subscribe my channel, share. Then those are preparing for the EAPCET examination. This is useful for you people, so please subscribe. Then next one of the question I will give as a homework for you people. The question is given in the 2023 May 12th కి ఇచ్చిన క్వశ్చన్ ఇది. The question వచ్చేసి vapor pressure of pure liquid A is, the vapor pressure of pure liquid A is 70 torr at 300 kelvins. It forms an ideal solution with 1 ideal solution with another liquid B, another liquid B, then the mole fraction of B is 0.2, and the total pressure of the solution is total pressure of the solution is 84 torr at the same temperature. Then the vapor pressure of pure liquid B, pure liquid B in torrs is, this is the question actually. So options are option A 140 torrs, then option B 90 torrs, then option C then 120 torrs, then option D that is 80. Yes, look at the question carefully. So you people have to do this question and answer the question in the comment section. So look at the question, what will be there. The vapor pressure of pure liquid A is 70 torr at 300 kelvins. It forms an ideal solution with another liquid B. The mole fraction of B is 0.2. Total pressure of this solution is 84 torr. Then at the same temperature, vapor pressure of pure liquid B is, that is question. Pure liquid P naught B you have to find out. P naught B find out cheyali. So formula vachesi P total equals to P naught A into mole fraction of A plus P naught B into mole fraction of B. Indulo P total find out cheyali. Okay. So find out cheyandi. So question ka answer cheyandi. Yes. So up to the now this session is end. Then next tomorrow some more problems we will discuss based on the solutions itself. Then one more topic, that is ideal and non-ideal solutions. Then colligative properties also you have to discuss. Then next, so those are preparing for the JEE Mains and NEET examination or EAPCET examination. So please save them, subscribe my channel. Then many of the subscribers are there. That is very useful to see to more students those are preparing for the EAPCET examination. Thank you. Just say answer, all of you. What is the answer for that particular question? Answer the question, all of you.